So hi everybody, it's Denise Ellsworth up in my upstairs bedroom, new office via webinar. So glad you could all come and join us today. We have a session with Heather Holm. If we had a more perfect world, we'd all have been together yesterday in person with Heather down in Columbus for the Pollinator Summit. But Heather was excited and anxious when I asked her, can you join us? And she threw her hat in and said, I'd love to do a webinar instead. And she's also coming back in October to keynote our one-day insect university. So we get a teaser today with Heather, and then she'll be back in person. Hopefully we'll all be together down in Columbus in October. So if you haven't already entered in the chat pod, maybe your town, and that just gives us a feel for who's joined us today. We have about 70 folks online. So we are going to record today's session, and I'll post the link to that recording once it's processed. And you're welcome to share that, that link with others who might be interested. So I first met Heather several years ago. She comes to Ohio quite often to do speaking programs. She's a biologist. She has a background in landscape design, and of course is an amazing author. For one of our classes this year, Heather, we're using your book on native plants and pollinators. And I was telling Heather that earlier when we were practicing for the webinar that I use her bee book all the time. There's some really great, she's a wonderful photographer, has a great eye for laying out information in a clear way, and a lot of great tips for ID. So I'm gonna turn the screen over to Heather, and she's gonna walk us through a kind of an introduction to some of our solitary bees and a focus on a few of those specialist bees. So Heather, let's see, I don't know if I need to unmute you. Let me go ahead and try that.
Looks like I've unmuted myself. Is that correct?
Okay. Yes, awesome, great. I'm gonna mute myself. So thanks, Heather.
Thank you. So everybody can see the presentation before I get started?
Yes, it's all up on screen. Looks great.
Awesome. Well, thanks, Denise. Under different circumstances, it would have been nicer to see everybody in person, but here we are, and thank goodness for technology. And I don't know about you, but I'm really thankful that spring is on its way, and we can get outside and really start to enjoy plants and pollinators. So Denise asked me to present today on some solitary native bees, and I hope I don't inundate you too much with too much bee information. I've tried to weave in a little bit some plants. What I haven't included, which I typically include in my presentations, is some tips and tools for how to garden for bees. But we can maybe hopefully carve out some time at the end of the session for questions on that. But there'll be a few things that I'll touch on based on the bees' nesting habitat that will give you some ideas of, first of all, what and where to look for bees, and how you can think a little bit differently about how they may be looking for places in your garden to nest. So, and I'm assuming that most of you in attendance today are gardeners and are also as curious about plants as you are about pollinators. So we'll talk real briefly about some bee diversity, and I'll get into a little bit more detail about bee habitat, where many of these solitary native bees nest. And I'm gonna touch on a few specialists. So some of you may not be familiar with bee specialists, but they are bees that only collect pollen from a certain kind of plant. It could be quite broad. They may collect pollen from an entire plant family, but some are much more narrow specialists, and that may mean they will only collect pollen from a certain genus of plants, such as goldenrod, for example. So I'll touch on a few specialists so you get a sense of some of the plants that are critical, especially at what I call the bookends of the season, the early spring plants that are really critical, as well as the fall plants that many of these specialists need. So with that, I'll get started. I look forward to any questions at the end. I don't think we'll be fielding them during the talk, and I know Denise said many of you know a lot about bees already. So you probably already know about our bee diversity in North America. We have over 4,000 species, and Denise can correct me at the end of the presentation, but estimates online say that in Ohio you have close to 500 species, and that sort of aligns with where I live in Minnesota. We have approximately 450 species. So for some of our bigger states, that seems to be pretty typical. There's much higher bee diversity in the southwestern states. But for us in the upper Midwest and Northeast area, 500 species is pretty typical. And so for a general audience, many people think, well, we only have one kind of bee, and it's a honeybee. And so for folks that haven't really, delved into what are pollinators and how many different kinds of bees we have, they generally base their model of bees on the honeybee. And that kind of makes my life difficult sometimes, because as many of you already know, honeybees have very different lifestyles than the native bees we'll be talking about today. So they, of course, are social, highly social bees nesting in managed hives, anywhere from 10 to 50,000 bees living together. And of course, our native bees, as you can see on this slide, most of them, the ones we're going to be talking about today, about 90% of the native bees are solitary. So that means just one single female bee is doing all the work of collecting nesting materials, pollen and nectar, and building the nest so that she can lay her eggs to produce the next generation of bees. So she does all this work by herself, and that's very noble, and at times a pretty precarious situation, depending on when she chooses to be active during the growing season. So most of our native bees we'll be talking about today are ground nesting, and I'll be featuring a number of different genera that nest in the ground. Not all ground nests are equal. Some of our native bees like to choose a specific soil to nest in, and females may also choose to nest in aggregations or many nests clustered together in an ideal situation. So our native bees are short-lived, but that's the good news is we have so many different kinds of bees, and each bee has its own seasonal phenology. So some of you I saw in the comments are starting to see some of our early solitary bees. I saw Andrina come up, and they have a very short window of time that they are active. So a given genus can have over hundreds of species, but an individual species is only really active for 2 to 6 weeks during the growing season. And of course, bees, we can think of them as a vegetarian. They essentially have a plant-based diet of pollen and nectar. And each of those 2 floral resources is providing bees with different nutrient components. Pollen is their primary source of protein and fats, as well as some minerals. And nectar provides them with carbohydrates, as well as amino acids. So they need this complement of those two pieces of food, especially when the mother bee is collecting those 2 materials to feed to her offspring. And now it's as I mentioned earlier, the females are doing most of the work in the bee life cycle. I call them, they're the nest, the whole housekeepers, the grocery shoppers. So they're out doing all the collection of pollen. Males have a pretty limited role, and we'll talk about their role, of course, but it's important to, so I'm not discounting males. And as I mentioned earlier, we'll be touching on these pollen collecting specialists. And so many of the bee genera have a number of pollen collecting specialist species. And so we're most concerned about these specialists, especially with climate change and perhaps the mismatch of when these bees emerge and the plants flowers. So going forward, it'll be important to be aware of what specialists are in your area and what plants you can provide for these specialists. And so the females are grocery shoppers. I know you learned about bumblebees in your last session, so I'm not going to talk much about them today because they make up part of that 10% of native bees that have a social lifestyle. But bumblebees and honeybees have a different way to collect pollen to bring back to the nest. They both have a pollen basket. So you can see on that left image, the pollen is mixed with nectar and packed onto this pollen basket onto the hind leg. Whereas most of our other native bees, the solitary bees we'll be talking about today, are generally collecting dry pollen grains and brushing them to some sort of structure. And that's either on hairs that they have on their hind leg, or in the case of bees in the leafcutter bee family, they're collecting pollen on the bottom of their abdomen. So these different grocery shopping bags or pollen collecting techniques will often dictate what plants a bee may preferentially visit and how or if they choose to collect pollen from that particular plant. So I'll just talk briefly about the bee life cycle, because today we're talking about solitary bees. For our ground nesting bees, many of them only produce one generation per year, especially in our northern latitudes. So that means that the adults are emerging given their seasonal phenology. If they're a spring emerging species, the adults will come out of the ground in spring, they will mate, and then the females then begin looking for an ideal nesting site to construct a nest. So the life cycle is four parts or life stages: egg, larva, pupa, and adult, the exact same as a butterfly life cycle. And you can look at this life cycle as essentially being 12 months if we're talking about a solitary bee that only produces one generation per year. Typically, a lot of our native bees are overwintering or suspending their development in a pre-pupal state. So the larva finishes consuming those pollen and nectar provisions, and then it spins a silk cocoon to enclose itself. And that's how a lot of our native bees, especially ones that emerge in late spring through fall, is how they are overwintering. So our native bees, the majority of them are nesting in the ground, and the female is excavating a nest. She starts with excavating sort of a main burrow shaft, and my illustration is very crude, so you'll have to just think of all the different ways in nest architectures all these different types of bees can construct. Some of our native bees have very shallow nests. For example, the squash bee, which is a squash specialist, they typically have very shallow nests of no more than 5 to 6 inches deep. Some of our other native bees will excavate pretty extensive and deep nests. And from the main burrow, the nest architecture varies, but they're essentially building these little offshoots from the main burrow and individual brood cells where they will deposit pollen and nectar. So it's that combination of pollen and nectar, or it's also sometimes called bee bread, that the native bees are depositing in the nest. And the female will have to make many trips back and forth to flowers in order to have enough large enough bee bread in order to lay a single egg. And so if you nest in the ground, there's some frequency when the soil will become saturated. So native bees have a number of different ways, either above and below ground, that they waterproof their nest. And I'll talk a little bit about some of those ways when we feature some of the genera. So when I talk about ground nesting bees to gardening folks and the general public, I created this graphic a long time ago because for the general public, people associate bees with stinging yellow jacket wasps that nest in the ground. And it's important to help educate others, and I know some of you are already very savvy, that these solitary ground nesting bees generally aren't aggressive nor do they defend their nest. And since it's only just a single female bee doing all this nest construction in a very short window of time, a couple of weeks, and on top of that, she has to go collect pollen and nectar, lay eggs, and perhaps even line the nest with a different type of material, she frankly doesn't have a whole lot of time to defend her nest or interest. So I'm just asking, I put this graphic up often just to help people educate others that the differences between these two insects is the one is a solitary nester and the yellow jacket wasps are a social colony. And generally insects that nest socially with many insects together, they have a higher propensity or reason to defend their nest. And that's the ground nesting insect typically we get stung by in our gardens and landscapes. So I'm going to talk a little bit about the ground nesting bee emergence. I saw in the comments that some of you are starting to see bees. I was excited because I saw my first bees emerging two days ago. And if you already know where a nesting site has occurred in the past, that's a great place to check out the following year at the same time. And that's exactly what I did this week. I have a large nesting aggregation of cellophane bees in my neighborhood. So I went over there to see if there were any bees out. And the first thing I look for is the emergence holes. So from that complex below ground nest architecture, each of those individual bees developing in the brood cell, when they pupate the following spring or in the fall, depending on what kind of bee they are, the individual adults will excavate their way out, generally vertically up the ground. And so the first thing I look for are these emergence holes in the area where I knew where a previous nest was the previous growing season. And I started to see emergence holes a few days ago at this particular site. And with most native bees or all native bees, the males typically emerge from the nest before the females. And that includes both ground nesting and cavity nesting bees. So that we call that a protandrous emergence. And if there's any botanists listening, same terminology for used for flower development. And so why do the males come out first? Well, they're generally fed a smaller diet and they are able to finish larval feeding before the females, and they generally develop a little bit quicker than the females. And having the males come out first gives them an opportunity to get their bearings, perhaps put some pheromones on some nearby plants. And the other behavior you may see especially with ground nesting bees, is the males will start to patrol over the nesting area, and they're waiting for the females to come out. I posted a video on Facebook this week of that, a slow motion video of the males flying slow over the ground waiting for females. So the females generally come out a few days to a week after the males. And for most of our solitary bees, the mating occurs after the females come out. And then once the female has mated, she starts to look for a new nesting site. Some of our solitary ground nesting bees, the females may use that emergence hole that she created, or an emergence hole from another bee, and use that as a starting point to start excavating her own nest, or she may just choose a space nearby that was near the nesting aggregation from the previous growing season to excavate her nest. So there's the female. So this nesting population that I found 2 days ago, the males came out in the morning, and by the afternoon there were 3 or 4 females that had already come out, which was surprising. And they were mating, and then by the following morning when I checked on the area, 3 females had already excavated their nests overnight. So what do male bees do in the spring this time of year? Well, many of those early spring solitary species, the males will tuck themselves into those emergence holes so that they can stay warm, because I don't know about you, but we have some temperatures that fluctuate a lot this time of year. And as Denise put in the comments, we are supposed to get snow tomorrow, which I hope we don't. But these poor males that are already out have to keep themselves warm. So they'll often tuck themselves back into their emergence holes. And this is the case for many of our early spring species. So nest site selection for many of our solitary nesting bees, the soil type will often be where a female bee may choose to excavate a nest. And you can see from the soil triangle, many of our native bees like well-drained soil, whether it's pure sand or loamy soil, but they generally try to avoid really, really heavy soils such as 100% clay. We do have some odd native bees that can nest in those really heavy soils, and they would be collecting water to help soften the soil for excavation. So nests for solitary bees can occur in aggregation. So that top left image you'll see of cellophane bee nests, those are all individual females that are excavating those nests, but they preferentially like that soil type. And the second thing that's very important is that site is probably close to some of the key forage plants that they need to visit once they come out of the ground as adults. So nests can occur all over the place. I've seen them in residential lawns. I find nests if I sit quietly in my garden and watch a bee land on the ground and tuck themselves under leaf litter. So some of the solitary ground nesting bees can be quite secretive, and it's hard to find their nests. Generally, this time of year in the spring, before vegetation starts to grow up, this is the best time of year to look for ground nesting bee nests. They do resemble ant hills, and so many of those females who are excavating the nest will deposit the soil around the nest entrance, and the nests really do resemble ant hills. So take a closer look if you think it's an ant hill. If you don't see any ant activity, then it could very likely be a ground nesting bee. So I'm going to feature some genera today, and the first one is the cellophane bees, or bees in the Colides genus. Some of my favorite bees, and this is the type of bee I found 2 days ago. We have a few, 3 or 4 species in our area and in your area that are active very early in the spring, and all ground nesting and solitary. This genus has a few specialists, some Midwestern specialists of prairie clover and Northeastern specialists of goldenrod. So those are the little blips on my seasonal phenology chart of Colides that you may find later in the growing season. But generally, most people observe Colides earlier in the spring. Now, Colides are a little unusual. They have very short tongues, and the tongues are two-lobed or bilobed. And they line their nest with cellophane-like material, which is why they get the common name cellophane bees, or also plasterer bees. So the females have this very large gland in the end of their abdomen called a Dufour's gland. And as they prepare a brood cell, they want to waterproof it. So she secretes some fluid from this Dufour's gland and then uses her tongue to paint the fluid onto the soil walls inside of the brood cell. And it's the mixture of her saliva and the Dufour's gland secretion that creates this cellophane-like material that waterproofs the inside of the nest. So most of our cellophane bees, but not all, have white hair bands on the abdomen. The females have a very large Dufour's gland compared to some of our other solitary bees. So their abdomens are quite robustly shaped, you could say. The females collect pollen on their hind leg as well as on the side of their thorax. So if you're familiar with mining bees, which I'll talk about next, they have a similar pollen collecting technique. It can be, if you have a side view of these bees and are trying to figure out if it's Colides or Andrena, sometimes just looking at pollen collection can be confusing. Colides, though, most of the species have a heart-shaped face. So you can see in the upper right image, the eyes are converging below, and they don't have prominent facial fovea like Andrena do, and I'll show you what the fovea are in the next couple of slides. The males are cute. They have these very hairy faces, and all males, that's the first thing to look for if you're trying to determine gender. Females will always have longer hairs or some sort of structure to carry pollen. Males tend to have more slender legs and less hairs on their hind legs in particular, because they don't collect pollen. So here's an example of a Calides nesting aggregation. This is at another site in city where I live. It's a park, and this dirt footpath has been a hotbed of a number of nests for a number of years. So you can see the nests all lined up along this footpath, and as the females are not choosy about which side of the footpath or the orientation, but they basically like the soil type. It's very sandy loam soil, and about 500 feet from where this early spring species nest is a wooded ridge that's filled with red maple trees. And generally for this particular Calides species, the first spring plant that they visit is red maple flowers. So they need to set up their nesting location in a habitat that's undisturbed, has the right soil type, and that is in close proximity to the forage plants that they need. And the red maple can be a hotbed of activity. This is a video, but I don't think I'll attempt to play it with our connection today. But the video would show many bees flying around frantically around these red maple flowers. And those are the male Calides. So if males are not patrolling over the emergent site where waiting for females to come out, their next opportunity to find a female for mating is to go to the first plants in bloom. And this is only the case, of course, for spring nesting species. So you'll see a lot of frantic flying activity around many of our early spring flowering trees and shrubs, including willow, for example. And most of that activity is generally male bees looking for females. Next genera that I want to talk about is the Andrena, my favorite genus. The mining bees, or miner bees they're called. And this is a very diverse genus. We have over 500 species in the US and Canada. Most of the Andrena species are, about 75% of them are spring active. So on that seasonal activity chart that I'm showing, that is 75% of the 500 species that are in the spring. So I saw some of you have already seen some Andrena, which is awesome. They come in all different sizes, but are generally the larger mining bees can be a little bit bigger than a honeybee. And there's also some fairly small mining bees that can get a little bit maybe smaller than a sweat bee. So they also have preferential soil types that they like to nest in, generally well-drained soil, sandy or sandy loam soil. But some of our mining bees are very common and will nest right in the middle of lawns. Others are a little more picky and secretive and like to nest in different places. So as I mentioned, Calides and Andrena, or the females, both have hairs on their hind legs and the side of their thorax to collect pollen. And the Andrena gets the common name the armpit bee, because that pollen gets packed up so high on the hind leg and on the side of the thorax, it looks like pollen's in their armpits. One thing to look for with Andrena, really easy thing once you know what to look for, is what I'm showing on those bottom images. Andrena have these depressions between their compound eyes and their simple eyes called foveae. And so you can see on the middle and bottom right image, those depressions are often filled with a different colored hair. And so if you get the right angle, if you're taking a photo of a bee on a flower, you can often easily spot those facial depressions, which will immediately lead you to know that you've just photographed a bee in the Andrena genus. The males they're sort of skinnier than the females. They have this anvil-shaped head, very blocky head, long antenna, skinny hind legs, and many of the Andrina males also have what dense hairs on the bottom of their face. Looks kind of like a mustache. If the dense hairs are absent, the face can be bare and have yellow or white on the clypeus. But good thing to look for is, you know, the slenderness of a bee, the slenderness of their legs, the length of their antenna. That can start to help you, lead you to understanding the difference in gender, and those are all common traits of male bees. So I wanted to highlight a couple of critical spring plants. I saw someone mention willow. So besides red maple, willow is an absolute hot spot in the spring for many of our solitary native bees. So if the males aren't patrolling around nesting sites, they're over at willow flowers flying around, getting nectar when they're taking a break, but generally just flying around frantically around the willow flowers. And willows have separate male and female flowers. So the female flowers are providing nectar and the male flowers are providing pollen. You would think it's a wind pollinated plant, but our willows in Eastern North America generally are insect pollinated. So very important plant to have if you have the space for a willow in your yard. You'll find some of the first queen bumblebees out nectaring on willow, and many different kinds of solitary bees, including cuckoo bees, will be visiting willow flowers. Willow I like to highlight because it probably supports the most pollen collecting specialists, 14 species in Eastern United States. And it's really nutritionally significant as well. The pollen has a 40% protein content. So for those female bees that need to collect pollen and stock in their nest, this is a very nutritious pollen source for native bees. Just want to show you one of the willow specialists. This is Andrina andrinoides, and beautiful red abdomen on this bee, and she preferentially nests in really sandy compacted soil. And of course she has to set up shop, her nest near where many willows are blooming, and that's the case with this particular female that I photographed. She was nesting in bare compacted sand, probably 50 to 100 feet from 3 or 4 willow species. So each of those willow species will provide a nice flowering phenology so that she can successfully provision her nest with willow pollen. So back to mining bees in general. So if you're out and about, even with social distancing, and you have early spring woodland wildflowers beginning to bloom, and later some of our native shrubs, you're primarily going to be finding bees in the Andrina genus visiting those kinds of plants. And as I mentioned, we're very diverse, so you'll find perhaps even in some cases 3 or 4 different species of Andrina visiting things like early spring flowering shrubs. One in spring specialization in the Andrina genus is hydrophyllum, or waterleaf. And this is an example of, and this is the case for many plants, plants are providing different things for different bees. So this waterleaf is generally a highly sought after plant in early spring bees that are collecting or feeding on the nectar. But there's very few bees that will collect the hydrophyllum pollen. And one of those bees is the pollen collecting specialist, Andrina geranii, that is a really tiny mining bee. Remember I mentioned they come in different sizes, and she's particularly small. But if you start to look closely at bee visitation to flowers, you can start to parse out, what is the bee doing? Is it sipping on nectar, or is it, in this case with the specialist, hanging out on the end of those stamens in order to collect the flower's pollen? Mining bees also specialize on spring beauty, and I know some of you said that's already blooming, and spring beauty has that beautiful pink pollen that the specialists get their pollen collecting structures packed with that. So that's a fairly common specialist that you have in your area in Ohio. Other specializations for spring woodland flowering plants include geranium. There's one specialist featured on the right image here, Andrina distans, that is a pollen collecting specialist of geranium. That picture is unusual because generally I see the specialist upside down or butt up in the air as she collects the pollen. So that's an unusual picture for her to be right side up on the flower. Also, early spring species like mason bees like to collect geranium pollen. So back to mining bees in general, probably the most pollen collecting specialist relationships in this genus. And so if we're moving into the summer months, most of the Andrina species active in the summer will be specialists on plants like I have featured on this slide, sunflowers, coneflowers, black-eyed Susans, and yellow coneflower. And then in the fall, most of the Andrina species are either an aster or goldenrod specialist. So they're coming out sometimes in mid-August all the way to mid-September. And so that those females have a much shorter window of time to collect pollen from asters and goldenrods, provision their nests successfully before they may perish with cooler temperatures. All right, we're moving into some metallic green sweat bees, and this is so different than presenting to a live audience because I want to ask you something, but I'll keep going and we can touch on this at the end. I always tell folks don't start BID with the metallic green sweat bees because we have 4 genera and many species, and they generally can be pretty hard to tell apart. What's different about the life cycle of some of our sweat bees is that many of the females will mate in the fall rather than in the spring, like I illustrated with that cellophane bee. So in producing multiple generations per year, they will produce reproductive females in the fall. So if Jamie Strange talked about the bumblebee life cycle in your last session, many of our sweat bees have a similar life cycle where females mate with males in the fall rather, and then they overwinter as adults. And then since they've already mated, they immediately start nest initiation the following spring. And that's the case with the metallic green sweat bees in this genus Agapostemon. So they generally, sweat bees will produce more than 1 generation per year, even in our northern latitudes. The Agapostemon genus is a little bit easier to identify. They generally tend to be one of the larger metallic green sweat bees. Their eyes, Denise showed a picture from a page from my book, but sometimes you can start with the eye shape for the metallic green sweat bees. It's not a 100% fail-safe approach, but it's a starting point. And Agapostemon tend to have not too much indentation on the inner part of their compound eyes, so the eyes fairly oval appearing. The other piece or characteristic of Agapostemon is they have, someone described it as someone took an ice cream scoop and scooped out 2 lobes out of the back of their thorax. So the propodium has this very defined ridge where that arrow is pointing on that left image. So it's all about getting many shots or photographs of these bees while you're out in your garden so that you can help you start to identify some of these metallic green sweat bees. The males in this genus generally look fairly similar. They have a metallic green head and thorax, and then the abdomen is black with yellow bands. So advanced level folks will start to differentiate the males into different species, but generally if you see a metallic green sweat bee like this, it's going to be a male in the Agapostemon genus. So like other solitary ground nesting bees, Agapostemon also likes well-drained soil, sandy loam soil, loamy soil. I've seen large nesting aggregations in really sandy sites in farms. The picture on the right I took in my own yard, and that's an example of just, I was sitting quietly on the steps up to my front door, and a metallic green sweat bee dropped on the ground next to me, and then she disappeared under the leaf litter and plant debris, and I just gently pulled that back, and that's where her nest was. So there's a variety of situations these particular metallic green sweat bees may choose to nest. And it also illustrates that you probably have more nests in your gardens and landscapes than you may realize, because many of these bees are quite secretive. Oops, sorry, I meant to delete that slide, same slide. Moving on into the summer. So I know we're sort of stuck in spring mode right now, but this is an example of a summer bee, what I call a summer bee. So the Melissoides genus, or the longhorn bees, they generally start to come out in late June, but are more prevalent in July and August. Many bees in this genus are also specialists. Now the females, they're much more robustly shaped, they're wider, and the other characteristic that's sort of easy to see even without taking a photo is the females have these very long hairs on their hind legs to collect pollen, and people call them often call them chaps. So when those hairs are loaded with pollen grains, it looks like the female is wearing cowboy chaps. The males, the common name longhorn bee is because the males have extremely long antennae, much longer than the females, and sometimes ridiculously long antennae. So that's something to look for. And bees in the Melissoides genus, many are specialists. Most of the plants they specialize on belong to the Asteraceae family. One example I have here is the thistle specialist. And we've long sort of had a hate for thistle species because many of our thistle species are introduced and invasive. Thankfully, the Xerces Society and other organizations are starting to highlight some of our beautiful native thistles. And this is a picture of the specialist visiting pasture or field thistle. So we can grow thistles in our garden as long as we're growing the right ones. And thistles will support a specialist like this beautiful longhorn bee. So you can look for Melissoides generally visiting Asteraceae flowers or composite flowers. So they like shallow flowers. So the picture of the thistle is kind of unusual because of the long, dense flower structure. But generally they like daisy-like flat top flowers with shallow flower corollas. Okay, let's move on to the cavity nesters. So this makes up approximately 30% of native bees. Cavity nesters, have to tip my hat to them because not only are the females collecting pollen and nectar and making many trips to do so to put their bee bread inside the cavity, in addition to that, they are collecting different natural materials. So they may be busy collecting mud or pieces of leaves or even tree resin. And they're using those natural materials to make walls. So you see on my crude illustration there, the brown walls in between each individual larval cell represent some kind of natural material that the female bee is collecting in addition to pollen and nectar. Some of our cavity nesting bees, so all with the 30% in many different species, some preferentially like to nest in wood, and they're generally using pre-existing cavities so that the holes in the standing dead tree were likely created by beetle larvae, and the native bees come along and use those once they're unoccupied. The one exception would be the large carpenter bee that is a wood excavator and will excavate its own nest in wood. But generally, all of our other native bees are looking for some kind of pre-existing cavity. And the cavity orientation and preference is going to depend on the species as well. So you can imagine those holes in that standing dead tree I have pictured here are generally probably horizontal holes. Some cavity nesting bees almost prefer near vertical cavities, and that would be in a plant stem, for example. So bee larvae are not as cute as monarch caterpillars or the like. I put up some trap nests just to get some images of some of our cavity nesting bees last year, and these are, both of these images are of the orchard mason bee, an early spring bee that likes to use mud as the nest lining and brood cell division walls. So you can see those walls are slightly curved, and that curvature helps the bee larva, once it becomes an adult, it helps orient the bee so it knows which way out of the cavity is the exit. And those larvae are sort of propped up on their ends and chewing and consuming the pollen and nectar that the mother mason bee has provided for them. This is an example of a late spring summer cavity nesting bee. The Hyriades, they're very small sized, very heavily pitted head and thorax. You can see there's the punctures in that top image. We call that, almost looks like golf ball like pitting. And this bee belongs to the same family of bees. As you can see in the top image, they collect pollen on the bottom of their abdomen. So she's propped out there on the end of a bee balm flower, brushing bee balm pollen onto her abdomen. These bees are really unusual, or not unusual, but one of the few bees that will use resin to line their nest. So that image on the bottom left is showing the inside of a resin bee nest. And so resin can come from a number of different plants. Often it's from pine sap. Honeybees, for example, may collect the sticky resin on cottonwood tree buds. So there's a number of different plants that we have that aren't necessarily insect pollinated that are providing these additional nest lining materials. And leafcutter bees is a very large genus of bees, the Megachile. The females tend to have really long brushes of hairs on the bottom of their abdomen for pollen collection. They have a number of sort of, I call hilarious behaviors, the butt up behavior. If they don't want to collect pollen from a flower, they'll stick their abdomen up in the air as they forage for nectar. And you can see on this slide, they're very opportunistic nesters as a genus. So some nest above ground in cavities, other species are ground nesting. There's even a few species like that image on the bottom that will nest in cavities in wood. They get their common name leafcutter bee because they utilize pieces of leaves to line their nest. They will also make leaf cylinders inside the nest. So that bottom right image is of 3 leaf cylinders lined up one after the other, where the female bee has cut the leaf pieces, overlapped them, and then created this leaf cylinder inside the nest before she starts to collect pollen and nectar and lay her eggs. So a lot of extra work just to give the bee larva this extra envelope inside of the nest. And they utilize a number of different plants, but they seem to preferentially like some plants over others. You'll find them, if you have redbud, especially in the east, they love redbud. I find them utilizing ash tree quite a bit, which is unfortunate with emerald ash borer, but we still have ash seedlings growing where they'll utilize those. Maples and dogwoods, roses is another favorite. And you can see the different shape cuts on the picture here. The circular shaped pieces are used to cap that cylinder, and the more oval shaped pieces the female would use to make those cylinder overlapping pieces. Okay, I'll finish off with Hylaeus. And so I talked about grocery shopping and different ways females collect, pack, and carry pollen. Well, this really tiny bee is unusual because the females don't have any external pollen collecting structures. You can see the female in the bottom right image. Her hind legs are bare. She doesn't have hairs on the bottom of her abdomen. So these tiny bees will actually store the pollen and nectar in their crop as they consume it on flowers, fly it back to the nest internally. And then when they get to their nest in a cavity, they will regurgitate those materials and to place them in a brood cell. Now their provisions are much more liquidy than the bee bread that I showed in my illustration, or that mason bee nest. So she needs to have a way to make sure the liquid provisions don't flow out of the cavity. And she belongs to the same family as the cellophane bee that lines its nest with that glandular secretion. And Hylaeus actually just use their saliva essentially to make that cellophane-like lining inside of the cavity, which helps keep the liquid provisions in and keep water from infiltrating the nest while the larvae develop. So pretty amazing way to collect provisions. People often mistaken these bees for mason bees, or excuse me, mason wasps, because they resemble mason wasps. They're black and yellow coloration. Okay, we have also some wood nesting bees. I'm not featuring sweat bees because sweat bees, or many of them, because Halictus, lasioglossum, many of those sweat bees are more social nesters. So today I'm trying to stick with our solitary bees, but we do have a few wood nesting lasioglossum or small sweat bees. And this is another example of a wood nesting bee common in the East, one of the 4 genera of metallic green sweat bees, the pure green metallic green sweat bee, the Ogochlora pura. And they like to nest in logs lying on the ground. You can see the white circle I've circled around some holes in the log. They're looking for wood that is starting to soften from rot, but it's not too wet. And the females will use those holes in a log as an opportunistic opening. And then she will chew out a small chamber or cavity inside the log to provision. So this is the only wood nesting metallic green sweat bee that we have. So the other 3 are all ground nesting. So if you see a bee in log or in wood, then this is the only kind of bee it could be. And the females have very sharp indentations, and the males on their eye where I have the arrow pointing. But I wouldn't, as I said earlier, don't get into identifying metallic green sweat bees if you're just starting out with bee identification. And then finally, our above ground bees are also nesting in flower stems. I show this picture of flowering goldenrod because in the fall and in this time of year, early spring, a lot of questions fly on social media about when is a good time to clean up my garden. Generally, I don't really like to recommend anybody cleaning up any gardens. The more natural materials and leaf litter you can leave in place, the better. But the reason I'm showing this picture of live growing goldenrod is many people believe when they hear that native bees nest in stems that they're nesting in the live growing plant material pictured here, and that's not the case. They are generally utilizing old flower stalks from the previous growing season. So these are just a few examples: mason bees in the Hoplites genus, and small carpenter bees, which are very tiny, much smaller than the large carpenter bee. They both preferentially like to nest in plant stems. And those plant stems generally that they prefer have a pith-filled center. So they appear solid, and in the center is like a white styrofoam pithy material. And that's what the females chew out a long linear cavity down an old flower stalk in order to create her nesting cavity. So that picture there, you can see she actually reuses the pithy material as her brood cell divisions. So each larva is developing in its own room inside of that cavity. So that picture that I have on the right is of my garden hillside. I probably took that picture maybe at the end of May, and I wait quite late in the spring to cut plant material down. And I will preferentially leave this flower stalk stubble from the previous growing season, which provides many opportunities for some of these smaller cavity nesting bees that like to nest in stems. And you don't have to leave as much as I have pictured here. Generally, they tend to like plants in the aster family. So your asters, your goldenrods, your cone flowers, your black-eyed Susans, bee balm as well, they also like, but those stems tend to be more fibrous and strong and smaller in diameter. They're not hollow in the center. They have a pith-filled center. So that's where you can easily provide a number of opportunities in your garden without doing a whole lot of extra work. And this is much more hygienic than putting up a bee house, for example, because the stems will break down over time and won't be reused from year to year. All right, I apologize, I don't have 6 slides to end the presentation today, but I didn't want to go over time for Denise gave me an hour. Generally, I end my presentations with talking about making sure you have something blooming at all times throughout the growing season, having a large diversity of flowering plants, preferentially native plants. And I hope I've inspired you to get outside and slow down. We all have some extra time on our hands, I believe, and get outside in nature or in your garden. Take a closer look at what different bees are doing when they visit flowers. What are they doing? Are they collecting pollen? Are they collecting nectar, and so on? And I'll end it with that. I just want to mention a great way or tool to get your bees identified by photograph is iNaturalist. I'm on there frequently, and I have my my profile name there on the bottom of this slide. So feel free to tag me if you have a question about a photo that you took of a pollinator. I haven't been focusing on doing a lot of bee ID lately, but I'm more than happy to check out anything if you tag me. So thank you.
Great, thanks, Heather. I'm glad you mentioned iNaturalist. I was gonna point out that you're on there a lot. You have awesome photographs. So folks, if you're trying to learn bees, you can see a lot of, you know, what Heather is seeing out there in the field throughout the season. So I definitely encourage you to do that. I'm gonna share my screen real quick because I just have I have a slide that has some of the different places you can go for information about Heather and the image that I mentioned with the green sweat bees and how you can learn some of them apart. So Heather, there have been some questions that came in. Just question, he lives in an area where there are a lot of clay soils and so wonders, will he not see mining bees there?
Mining bees will nest in like a silt loam or a clay loam, so that I'm not discounting the opportunity for mining bees to be in your yard. You may have fewer nests, but it's still possible. Yeah.
And folks, I do have that chat pod. If you have questions, you can go ahead and type those in. Roxanne had a question. So Heather, one of the, some of the folks that are in on today's webinar are taking a class that I have online, and we watched the video interview that you had pointed me to. And so Roxanne is asking about your comment about Dutchman's breeches and queen bumblebees, and she wonders if you've seen that association in other places besides Michigan.
You mean the queens visiting Dutchman's breeches?
Yeah.
Yes. Yeah, we see queens frequently here visiting Dutchman's breeches, and I'm in Minnesota, but anywhere Dutchman's breeches blooms, generally some of our early queen bumblebee species, Bimaculatus and maybe Impatiens, that would be sort of a phenological cue if that was the question, that you would find queens visiting that plant.
Okay. Someone posted an image to our website this morning of, I think it was a mason bee house that had a lot of resin on the ends of the tunnels. And so thoughts on what that might have been? I think you mentioned some.
Yeah, could have been Hyriades. So if it was in a supplemental nest, Hyriades like more horizontal orientation, and with a resin cap. That would be my first guess. We don't have a ton of cavity nesters that use resin, but Hyriades is the most common one.
Great. Mary asks, just to confirm, we should cut pithy plant material. I think you said not at all, but maybe if you have to cut it back, late spring?
Yeah, so right now all my plant materials up in my garden from last growing season. I won't get out there for probably 3 or 4 more weeks, and I just use big garden scissors and chop the material, and then I selectively leave some stubble. So it doesn't have to be every single plant in your garden. You can, again, think about those plants that I talked about, coneflowers, goldenrod, asters. Plants in the aster family tend to have ideal stems for nesting. So you can leave a few as a experiment, or you can leave many. It really is your preference.
So Carl is asking about bees that collect oil and where in the plant that oil is produced.
Yeah, that is a rare, it's one of the rarest families of bees that we have. And our native loosestrifes is one example, the Lysomachia, plants in the Lysomachia genus. So instead of those plants having nectaries, they have oil producing glands inside the flower. And the oil collecting bees have special brushes, or brushes of hairs on their forelegs that they brush the oil and collect it that way to take back to their nest. So, for example, I have world loosestrife, Lysomachia, ciliata, and there's a number of native yellow flowering loosestrifes that some like sort of moisture conditions, so you'll find them along wetland edges, but there are some that are more garden suitable that can tolerate drier conditions. So I definitely recommend looking for native loosestrifes from a local native plant nursery and trying those out in your garden to see if you can attract the oil collecting specialists.
Okay, let's finish up with a few more stubble questions. How do you recommend cutting that stubble back to? And with plants that have tall stalks that are falling over, what can you do with those?
Yeah, if you have plants right now and like really tall plants, for example, in my yard, Joe Pye weed is super tall, and by spring, it's pretty much fallen, the whole stalk has fallen over. So I generally don't leave those. I will bag sort of the really fibrous large stalks like that and put them out to the curb, or chop them up with my garden shears so they start to break down. So you're still, again, you're looking at plants that don't get as tall to select to make the stem stubble. For the stem stubble, you want to leave at least 15 inches. So if you're leaving 3 inches, remember my illustration of those cavity nesting bees all lined up in the cavity. A short stem stubble would make the cavity really susceptible to predators. So the longer the cavity, the better. You're ensuring you're going to have more bee larvae developing within that cavity. So I generally recommend 15 inches for the stubble.
Great, thanks Heather for a great webinar. Folks, if you could offer Heather a thank you in the chat pod, I'm sure she'd appreciate that. Really appreciate your time today. I'm sorry about your snowy day tomorrow, but I think you've inspired us with lots of great photography to go out there and keep hunting for bees. Everybody, thanks for joining us. We'll be back again next Thursday with Doug Tallamy. So enjoy your week, get out there this sunny day and post lots of images to iNaturalist. And thanks again, Heather.
You're welcome, thank you.